So structure question related to topic electrolysis from exercise 3. Exercise 1 is about multiple choice question MCQs. So that I will share with you and you can solve. In the first question, aqueous copper 2 sulfate solution can be electrolyzed using the carbon electrode. So if you are doing electrolysis of aqueous copper 2 sulfate using the carbon electrode, means the anode is made up of carbon, cathode is made up of carbon as well, and the solution contains these ions. So this one is connected with the positive terminal, that's anode, and the one which is connected with the negative terminal, that's cathode. So positive ions are attracted towards a cathode. Which positive ion will move? Always the less reactive positive ion will move. So when we check the reactivity, copper is less reactive. So in this case, the copper will move. So when this copper ion move towards the cathode, what will be the equation at the negative electrode? That copper ions are there. They will take 2 electrons and it will turn into copper atom. So the question is write ionic equation for reaction at a negative electrode or cathode. So what reaction occur at negative electrode? That the copper ions which are there in the electrolyte will take 2 electrons and it will turn into copper atom. Then for negative ion, we normally check the amount, but sulfate, nitrate, and carbonates never move. So we have 2 negative ions. We have sulfate ion and we have hydroxide ion. So in this case, the hydroxide ions are attracted or move towards anode. And whenever hydroxide ions are moving towards the anode, what is the equation for anode? Because it's fixed, when 4 hydroxide ions are there, they will lose 4 electrons and it will give oxygen plus 2 water molecules. That's why there will be bubble C. So the question is, a colorless gas was given off at the positive electrode or anode, and the solution changes from blue to colorless. We have to explain this observation. So what are the bubbles of the colorless gas? So we'll mention the oxygen is formed. At anode due to the movement of hydroxide ion. And why the color changes from blue to colorless? Because copper ions are blue in color. As these copper ions are removed from the electrolyte, the amount of copper ion decreases. So the color of this electrolyte, so concentration of the copper ion in the solution decrease. That's why the color of the electrolyte also changes. Or amount of the copper ion decrease. That's why the color is changing from blue to colorless. And you can also mention, because copper ions are moved and hydroxide ions are moved, so what we are left with? We are left with sulfuric acid. So initially, when we start the electrolysis, it was copper sulfate. But when we complete the electrolysis, as the copper ions and hydroxide ions are removed, so we are left with H2SO4. So copper sulfate will turn into sulfuric acid, or copper ion concentration decrease. That's why the solution turns from blue to colorless. In question 2, aqueous copper 2 sulfate is electrolyzed. In question 2, aqueous copper 2 sulfate can be electrolyzed using the carbon electrode. So it means we have 2 electrodes which are, using copper electrode, not carbon. So the previous question was, we were using a carbon electrode, but now we are using copper electrode. Means anode and cathode both are made from copper or consist of copper. So we have positive and negative ions. So aqueous copper 2 sulfate, what are the ions present? There will be a copper ion, there will be sulfate ion, there will be hydrogen ion and hydroxide ion. The movement of, remember, like anode and cathode are made up of copper, means this is an active electrode. Like it is, this electrode will react. In the electrolyte, there will be no change. First, the electron will move from negative terminal of the battery towards the cathode. So majority of the electrons are here at cathode. and electrons are removed from the anode, so most of the positive charges are there at anode. So for positive ion, always the less reactive positive ion will move. So in this case, the copper ion will move. So when the copper ion will move towards the cathode, copper ion will take 2 electrons, it will form a copper metal that will stick to the cathode, so the size of the cathode will increase. But to balance the removal of the copper ion, one of the copper atom will go inside the solution as a copper ion. So the equation will be opposite. At anode, what will happen? The copper atom turn into copper ion by loss of 2 electrons. So one side, the ion from the electrolyte turn into atom. Another one, the atom turn into an ion. But in the electrolyte, there will be no change. So the question is, write a word equation. So we have to write word equation for reaction at positive electrode. So what is the reaction at positive electrode? So because it's a word equation, so in a word equation, what we will do? We'll mention copper atom. Because initially we have copper atom at anode. Anode is a positive terminal. So copper atom turn into copper ion and give out 2 electrons. So this is a word equation for the change at anode. Then why the color of the solution does not change? So whenever we are doing electrolysis of aqueous copper sulfate using a copper electrode, the color does not change. What is the reason for that? Because the amount of the copper ion which entered the solution and the amount of copper ion which leave the solution will be same. So the concentration or amount of the copper ion does not change, or number of copper ion which leave, like which are going out from the electrolyte, is same as the number of the copper ion enter the electrolyte. So answer here that the concentration of the copper ion or amount of copper ion, you can also use, in the electrolyte does not change. And why it does not change? Because the copper ion move out from electrolyte is balanced with copper ions enter the electrolyte from anode. So the number of the ions enter and leave are same. That's why there is no change in the amount, or there is no change in the color of this electrolyte. And what is the large scale use of this electrolysis? So where we can use this electrolysis for purification of copper. If you want to purify the copper, we can have anode made up of impure copper. So refining of copper or extracting the copper. If you want to extract the copper, we can use this technique, or if we want to purify or refine the copper, we can also use this technique. So in this question, cell reactions are both exothermic and redox. Redox reaction means in which both oxidation or reduction happen, and oxidation is a loss of electron. When the substance lose electron, we call that as oxidation. And for substance which oxidation happen is also known as reductant or reducing agent. And reduction is a gain of electron. When any substance gain electron, we call that as a reduction. And for substance which reduction happen is also known as oxidant. Oxidant and oxidation is different thing. Oxidant is the substance help in oxidation, but by itself it is reduced. So The two terms are a bit confusing. The substance which is oxidation happen is also known as, or oxidation occur is known as reductant. And a substance which reduction happen is also known as oxidant. So how this cell works, the cell reaction. So how it will work, we have two electrodes, one is zinc, another one is iron. Which is more reactive, zinc or iron? And it's a dilute sulfuric acid. So acid is also there, means it contains hydrogen ion, sulfate ion, hydrogen ion, and hydroxide ion, because acids and alkalis are aqueous. So which is more reactive, zinc or iron?
Zinc.
Zinc. So zinc is more reactive, and always the more reactive metal has a tendency to lose electron. So what will happen? This is a cell. So more reactive metal lose electrons. So zinc atom, which is here, will turn into zinc ion. And when it will turn into zinc ion, it will lose electrons. So the equation for at zinc electrode, that the zinc atom changes into zinc ion by loss of 2 electrons. These electrons will travel and it will stop at iron, because electron can only move through a wire or the electrode, but not in the electrolyte. Electron cannot move through the electrolyte or the solution. So electrons will stop here. When these electrons will stop here, these electrons will attract the hydrogen ions. So when these electrons attract the hydrogen ions, so when one hydrogen ion is there, it will take one electron and it form hydrogen atom. When two hydrogen ions are there, they will take 2 electrons and it will form a hydrogen gas. That's why you can see the bubbles are there on the other side, and the size of this zinc electrode will decrease. So for what is happening for zinc? Zinc atom changes to zinc ion. This is a loss of electron or gain of electron. Zinc atom changes into zinc ion. More reactive metal always have a tendency to lose electron. So this is a loss of electron.
Zinc is reductant.
Yeah, good. So this is a loss of electron, as it is losing electrons. So the substance with lost electron, we call that oxidation happen. And for substance which oxidation happen is a reductant. And same thing for hydrogen ions take electron and turn into hydrogen gas. So means they gain electron. When a substance gain electron, what we call this change, we call that as a reduction. The change is called reduction. And the substance which reduction happen is known as oxidant. So that is the first part of the question they asked. In the first part, they asked which substance in the cell is reductant and which ion is oxidant. So which substance is a reductant? Zinc atom is a reductant. And which ion is oxidant? Hydrogen ions are oxidant. So here, you just have to write here, zinc is a reductant because oxidation happened, and hydrogen ions are oxidant because reduction happened for them. How could the voltage of cell be increased? I want to produce more voltage. What I should do? Here I'm using
difference in reactivity.
Yeah, so use two metals which are having a greater difference in the reactivity. So to increase the cell voltage, whenever we want to increase the voltage of a cell, we should use two metals which are having a greater difference in the reactivity. So example, here we are using zinc and iron. So we can use, instead of zinc, as we know the reactivity, we have like potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So in this case, we are using iron and zinc. But I want to increase the cell voltage. So what I can do, I can replace the zinc with magnesium. So, or I can replace the zinc with calcium. or I can replace the iron with copper. Any we can mention like greater difference in the reactivity, high cell voltage or more voltage produced. In question 4, titanium is very resistant to corrosion, like titanium does not rust. One of its use is an electrode for cathodic protection of a large steel structure from rusting. So this is a steel oil rig is there, which is a cathode. Cathode means it's connected with a negative terminal, and there's a titanium anode is there. And what are the ions present in the seawater? Contain hydrogen ion, hydroxide ion, and sodium ion because it contains dissolved salt. So define oxidation in terms of electron transfer. What is the definition of oxidation? In terms of
electron.
So loss of electron. So when you mention loss of electron, you'll score 1 mark. Then what happened? Because the ions which are present here in water, we have hydrogen ion. In the question, in the water, we have hydrogen ion, we have hydroxide ions, we have Na plus, and we have Cl minus. For positive ion, always the less reactive will move. So in this case, hydrogen will move towards cathode. So when hydrogen will move towards the cathode, the hydrogen ions take 2 electrons and it will form a hydrogen gas. So there will be bubbles there at cathode. And for positive, because it depends on whether it is a dilute or concentrated, but because of seawater, normally it contains greater amount of salt as well as the water molecules are higher. So this is a possibility that there is a possibility that Cl might move, or there is also a possibility OH might move, because it's not mentioned whether it's a dilute or concentrated. So both possibilities are there. Cl can also be moved, OH can also move. So if Cl will move, which gas will be there? Because if 2 chloride ions will move, they will lose 2 electrons and it will form a chlorine gas. And if hydroxide ions will move there, they will lose 4 electrons. It will form O2 plus 2H2. Yeah, even water is in comparison to salt, the water is in more quantity. That's true. Like when we compare the amount of water molecules, so it should be, but because the concentration of the water is not same, even for a seawater, different samples of a seawater have different concentration of the salt. That's why both possibilities are there. Like if you take example of a Dead Sea, which is containing a higher percentage of the dissolved minerals. So even for a sea, the concentration of the salt is not constant. It changes from one place to another. That's why I'm saying both possibilities are there, that if it is a concentrated, then Cl will move. If it's a dilute, then OH will move. So steel oil rig is a cathode. Name the gas which is formed at this. So which gas is formed at cathode? That is
Hydrogen.
Hydrogen. And as you can see, the third part, they say name 2 gases which are formed at anode. So why they're saying 2 gases? Why they did not say only 1 gas? Because both possibilities are there. So there, if it is a concentrated, what is the possibility that there's a chlorine gas? If it is a dilute, OH will move. So what is the possibility that oxygen gas will be there? So you have to write chlorine and oxygen both. Next question. The results of experiment on electrolysis using the inert electrodes are given in the table. Complete the table. The first line has been completed as an example, and you have to complete the remaining. First, if you have molten lead 2 bromide, first, what are the ions present in lead 2 bromide? It will contain lead ion, because lead 2, Roman 2, so lead is 2, and bromide means bromine is group 7 minus 1. Because it's a molten means it does not contain any water. So as it does not contain water, what will happen? The lead ions will move towards the negative electrode. That's why lead is formed at cathode and bromide ion will form at anode. And for a molten substances, the electrolyte is used up. Now the second one, look, whenever electrolyte is used up, first thing you can identify it should be molten, because only in a molten substances electrolyte is used up. If we have aqueous substances, the electrolyte is not used up. It might change its concentration, or it might totally change into another substance. So first thing, if you want to complete this, the last column, it's written used up. If electrolyte is used up, it should be molten. But what molten? Because potassium and iodine are moved, so it should be potassium iodide. So we should have molten potassium iodide. That's why the potassium ions will move towards cathode and iodide ion will move towards anode. If we have dilute aqueous sodium chloride, the first thing you have to identify the ions. There will be a sodium ion, there will be a chloride ion. There will be hydrogen ion and hydroxide ion. For positive ion, always the less reactive will move. So which ion will move?
Hydrogen.
Hydrogen, because hydrogen is less reactive. So if hydrogen will move, what will form? Hydrogen will form. For negative ion, we check the amount. It's a dilute solution. Dilute solution means it contains more water and less salt. So because OH is more, so if OH will move, when 4-hydroxide will move there, it will give oxygen and water. So water is already there. So what we write as a product, we'll mention whenever OH is there. So we'll mention oxygen. Then what happened to electrolyte? H is removed and Cl is removed. So what will happen? Amount of H and Cl will, H is removed and OH is removed. So amount of H and OH decrease. So it will become concentrated NaCl. It will be NaCl, sodium chloride, because that we are left with sodium chloride, but we'll mention concentrated. Why concentrated? Because the amount of water is decreased. That's why it is sodium chloride concentrated. If you are doing electrolysis, you cannot say molten sodium chloride. Practically, it won't be correct. Molten means when you supply the heat energy and melt the solid, that's molten. But here in aqueous substances, we don't supply heat energy. So it should be concentrated sodium chloride, not molten sodium chloride. Only acceptable answer for a positive electrode is oxygen. Water is not acceptable because water is already there. If any new thing is formed, that we have to mention. So they don't accept the water. If you mention water, it's not acceptable. As water is already there, it's an aqueous solution. Then we have aqueous copper sulfate. So what are the ions? Copper ions are there. Sulfate ions, hydrogen ion and hydroxide ion. For positive ion, we check the reactivity. So always the less reactive will move, so copper will move. For negative ion, we check the amount, but sulfate, carbonate and nitrate never move. So it will be hydroxide. When hydroxide is there, this will be oxygen. And what is this electrolyte?
H2SO4.
H2SO4, which is also known as sulfuric acid. So the electrolyte will turn into H2SO4, which is therefore sulfuric acid. Even they did not mention it's a dilute or concentrated, but that does not make difference to the result. Because even though it's a concentrated and sulfate is more, or if it's dilute and OH is more, but all the cases OH will move. As the sulfate, nitrate and carbonates never move. That's why that does not make difference if they don't mention whether it's a dilute solution or concentrated. So even it's more or less does not make difference. So why it forms a sulfuric acid? Because copper is removed and OH is removed. So when copper and hydroxide are removed, so we are left with H plus and SO4 minus. H plus and SO4 minus, which compound is formed? when we cross multiply, this 2 will come with hydrogen and 1 with sulfur, sulfate ion. So as a result, it will form H2SO4. And this H2SO4 is known as sulfuric acid. We don't have to mention it's a dilute or concentrated sulfuric acid because the electrolyte has completely changed. So if the electrolyte has completely changed, it means we don't have to specify. If the electrolyte remain the same and amount of water has changed, then we mention it's either dilute or concentrated. The last one, we have hydrogen ions are there, which is formed at negative electrode, bromide ions formed at positive electrode, and the electrolyte is potassium hydroxide. Yeah, that's good. So it is, because the bromide ions are moving, so it is aqueous concentrated potassium bromide. Because the ions which it contain K plus, Br minus 1, H plus, and OH minus. The potassium ions, hydrogen ions are less reactive, so hydrogen will move. That's why hydrogen formed. And because it's a concentrated solution, here you have to mention, because if it's a dilute, then OH will move. But it's a concentrated, so Br will move. That's why Br is moving. And what we are left with KOH, so potassium hydroxide will be the final product.